Alright, so now that I got all this flooring removed, you could tell it's almost as though this whole assembly in the middle here was all planned out well on paper, and then just in the execution stage they fucked it up. There's this big beam here, and that's carrying a good portion of the weight of the second floor and the roof above, and it's meant to rest on these two 2x8 studs, which themselves happen to land just 3 inches to the right of this floor joist, which has been conveniently doubled up here. It's the same thing on this side. That somewhat smaller beam lands on these studs here, and it's landed just 3 inches to the right of this doubled floor joist. And also in the middle, that one stud is carrying that one floor joist on either end, but it lands just to the right of that one. They would have gotten away with this because conveniently they build houses from the ground up. So first they would have been framing in all of these floor joists and then installing the subfloor over top. Now they've used this 3/4 inch thick 1x6, and they've installed it diagonal across the floor joist here. Only once all the subfloor is installed would they then have been framing in all the walls for the second floor and these studs for the beams above. And there wouldn't have been a second floor yet, so there wouldn't be a whole lot of weight on these studs, and it probably wouldn't have been completely obvious that they totally missed their target here. It would only really be after all the weight of the rest of the house was added in, and then 45 years later, this gap grew to a full half-inch dip in the flooring here. That actually makes it pretty hard to mate up the new flooring with it, and it also just makes it pretty difficult to cut out all this existing flooring because it's actually supporting a whole lot of weight. The only really option would be to cut each of them where they meet halfway across the floor joist so that they're still holding all that weight. I mean, I could also just wing it and cut halfway through each of these where I'd like, but there's a good chance I'd end up with the second floor on the main floor and then the main floor in the basement, and that's not super ideal here. To get around this, really, the only option is to take the weight off the subfloor before removing it. So I set up a jack in the basement and then got these 2x10 blocking pieces here and here, and then jacked them into place so that they'd be supporting all the weight of the studs over here. And so that took all the weight off the subfloor and then onto the blocking supported by the jacks. And then I could wrap around these floor joist hangers here, and those could actually hold up the studs. Then once I'm comfortable that all that weight's on there, I could take the jack out and I'd be comfortable that the subfloor isn't holding too much weight. Now the blocking actually allows for a full 1.5 inch on either side to support these studs, which is required by code, but it also leaves a pretty big gap in there so I can still run a duct in there again. Now on this side there's this whole post here and this beam here, and that's all aftermarket as well. It's being used right now to temporarily support this beam and spread it onto the two piles here and over here. So the idea behind this is once those two areas were supported, I was then able to cut out the flooring here, and now I can install a new floor joist that's going to run underneath these studs. Then I can put the new subfloor panel on top of it. Now the placement of the two piles was actually super intentional. So it's hard to see here, but in the basement there's the main beam that runs directly underneath there. And so this pile is actually sitting right on top of it. And then this pile over here is actually just on top of the back wall of the basement, which would be on a footing in the foundation. So these two supports being on opposite ends of the span of the beam and over those nice load-bearing areas is pretty optimal for lifting from. The other thing is I would not really like to jack directly from underneath it because there's only the one floor joist under here versus the two here. So if I start jacking up from underneath, there's a good chance I'd start pulling this floor joist quite a bit down, and I could end up with, when I remove the jack, a permanently deformed floor joist that actually has a bigger dip than I started with. Just shifted the problem from here over to here. Now the last reason for spreading out the weight across these two areas is these subfloor panels are meant to be installed with the joints all staggered apart. I believe they're actually required to be at least 2 floor joists spaced apart, and if I was jacking it up on this floor joist here, then the jack would be in the way of me shifting a new panel into here, so I kind of needed a way to still leave space for me to put the panel in place and have it support on either end. Now when I put this actual beam thing in here, I made sure that the crown was facing up so it would sort of oppose the stress that's all going on it. But what I've noticed over the last few days is that I've started to see the bubble is indicating the high point on this side of the beam is up here, and then on this side it's the opposite, it's up here. So that suggests now there is a big bow in it that's going down. I'm really hoping that when I remove all the weight from it, it does spring back, because these 10-foot long 2x6s were $20 each. The other thing is the interwebs specify you shouldn't lift up your house by more than 1/8 of an inch each day, and that's to avoid cracking all the other structural pieces in the house. And so this had to be done pretty slowly to get that full 1/8 inch out. Can definitely tell now that there is quite a big gap in there, so all the weight is certainly on this contraption now. The reason for all these big posts here is I was left with quite a number of 2x4s when I'm removing all those old walls, and lumber is pretty hard to come by nowadays, so I tried to use what I had and stagger a lot of the lumber in opposite directions here and then strap it all together. And that's because lumber tends to want to bow when you put a lot of compression forces onto it, and then it can blow out kind of catastrophically, and that's not super ideal for this project. The straps also just contain it if there is really much bowing that's happening. And I've also strapped it in those sort of strategic areas where all the weight is concentrated around, and those beams are going to want to spread apart. The other thing is this whole contraption here does give quite a bit of mechanical advantage, and so it really was not particularly hard to jack this up. The handle of the jack gives already a huge lever there, and then by the design of the jack there's a small piston with some small force that spreads over a much larger area, so you actually get the huge mechanical advantage of the jack. And then just due to the placement of the two piles, there's another huge lever, because this is quite a long lever arm relative to the short one, and so the 20-ton jack was probably pretty overkill. You know, this may look pretty bad, the way they've got this originally installed, but it's not nearly as bad as it looks. These studs are actually all fastened together with a bunch of nails, and so even though the beam itself is really only resting on these two studs, a lot of that weight is then being shifted over to this one, which itself is landed on a floor joist. That actually became super obvious when it came to this end, because I found that this stud, which presumably was the one carrying most of the weight, was bowing a lot out that way, and my thinking is that bowing was causing this board to twist as well, but because it's being stopped here versus this one is notched out, it probably is the cause of this huge crack that's formed. Now you can't even tell how big the gap actually was before, because over the last week I've been slowly clamping it back together. This was at least a full inch before, and now it's down to less than half an inch, I'd say. I may stop where it is right now, just because I've so far successfully not cracked this stud at all, and I'd rather not make this problem much worse than it already is. Now, the last thing I'd like to do before I get all the weight back on these studs is I'd like to drill some pilot holes diagonally through these, and then drive these screws through those boards, and that should help fasten them all together much better and hopefully spread that weight around. Now, I know it's not super ideal to use screws for structural framing because nails do have much higher shear strength, but I'm hoping that because I'll drive them in at a bigger angle, that shear force will be spread over a much larger surface, and so these hopefully will be able to withstand any change in that force that's going up and down on it. And really the other reason is just because nails of this size would be much harder to drive, and I don't think my neighbors would appreciate it. Overall, it's kind of rough to see that there's clearly been a bunch of planning that went into this, and then just at the last minute, it's like they free-handed it all together, but I'm hoping I can get this all resolved much nicer.